Have you ever looked up at the night sky and felt a sense of wonder, a feeling that you're staring at something impossible? We take it for granted, that silent glowing orb hanging in the darkness. But what if I told you that our moon is more than just a rock in space? What if it's the key to one of the greatest mysteries in the universe? What you're seeing now shouldn't be possible. It's a cosmic coincidence so precise, so statistically improbable, that it has baffled astronomers for centuries. This is the story of the moon's perfect orbit, a celestial alignment that simply has no business existing. Let's start with a simple yet mind-bending fact. From our vantage point here on Earth, the moon and the sun appear to be the exact same size in the sky. Now that sounds simple enough, right? But think about what that really means. The sun is enormous, about 1.4 million kilometers in diameter. Our moon is tiny in comparison, just under 3,500 kilometers across. For them to appear identical in our sky, there has to be a perfect balance of size and distance. And there is. The sun is about 400 times larger than the moon, but by an almost unbelievable coincidence, it's also 400 times farther away. This perfect ratio is what allows for the most breathtaking spectacle visible from our planet, the total solar eclipse. The moon slides over the sun with millimeter precision, covering the fiery disk completely, revealing the sun's ethereal corona. If the moon were any closer, it would block the corona. Any farther away, and it wouldn't cover the sun completely. It's perfect. Too perfect, some might say. No other known moon in our entire solar system has this unique relationship with its parent star. It's a feature exclusive to Earth. So the question becomes, why? How did this happen? Was it just a fluke? A one in a trillion cosmic accident? Or is there something more to the story? To understand the moon's orbit, we first have to understand where the moon itself came from. For a long time, this was a puzzle. Did the Earth capture it? Did it spin off from a rapidly rotating young Earth? These ideas had major flaws. The leading scientific theory today is as violent as it is elegant. It's called the giant impact hypothesis. The theory goes like this. About 4.5 billion years ago, not long after the solar system formed, a protoplanet roughly the size of Mars, which scientists have named Theia, slammed into our young Earth. The impact was cataclysmic, an explosion of unimaginable scale. This collision was not a direct hit, but a glancing blow. It was powerful enough to tilt the Earth on its axis, giving us our seasons, and to liquefy both worlds. A colossal plume of vaporized rock and debris was ejected into orbit. Over time, perhaps a few hundred years, maybe even less, gravity did its work. This swirling ring of superheated material began to clump together, coalesce, and eventually it formed the moon. This theory explains a lot. It explains the moon's relatively small iron core, because most of Theia's dense core would have merged with Earth's. It also explains why moon rocks, brought back by the Apollo astronauts, show evidence of having once been molten. For a long time, the giant impact hypothesis seemed to be the perfect answer. But science is never that simple. The neat and tidy story of Theia has some serious problems. The first major problem is a question of chemistry. If the moon is mostly made from the debris of this alien planet, Theia, then its chemical composition should be distinctly different from Earth's. Every planet in the solar system has a unique isotopic signature, like a chemical fingerprint. So, when scientists analyzed the moon rocks, they expected to find Theia's fingerprint all over them, but they didn't. What they found was astonishing. The isotopic signatures of many elements in the moon rocks were almost identical to those on Earth. It was as if the moon was made almost entirely from Earth material, with very little, if any, of the supposed impact of Theia. How is this possible? For the moon to be made of Earth material, the impact would have had to be so incredibly powerful that it completely vaporized and mixed Theia and a huge portion of Earth's mantle into a single homogeneous cloud. The problem is, when scientists run computer simulations, getting that outcome is incredibly difficult. Most models show the moon forming primarily from the remnants of Theia. To get a moon that looks like ours, you need a collision of a very specific size, at a very specific angle, with a very specific speed. The odds are astronomical. It's like trying to hit a moving target from billions of miles away with a bullet. and having that bullet not only hit the target, but fuse with it in a precise way to create a perfect spinning sphere. It pushes the boundaries of statistical probability. And that's not the only issue. There's the orbit itself. The giant impact hypothesis results in a moon that starts off in a chaotic, highly elliptical, or egg-shaped orbit. Over billions of years, tidal forces between the Earth and Moon would have gradually pushed the Moon outward and made its path more circular. And the Moon's orbit today is indeed very stable and nearly but not perfectly circular. It's also tidally locked. This means it rotates on its axis at the exact same rate it revolves around the Earth, which is why we only ever see one side of it, the man in the Moon. The far side remained a complete mystery until a Soviet probe photographed it in 1959. This tidal locking and orbital stability are expected outcomes of gravitational evolution. But the starting point and the final perfect result we see today are what continue to raise questions. Could a chaotic, violent birth really lead to such a precise, stable, and life-sustaining celestial partnership? Our Moon does more than just cause tides and light up the night. It stabilizes Earth's wobble. Without the Moon's gravitational pull, our planet's axis would tilt unpredictably. The climate would swing from scorching heat to deep freeze ice ages over and over. Complex life, let alone humanity, would have had little chance to evolve. So here we are, on a planet that is perfectly tilted, orbited by a moon that is the perfect size and distance to stabilize our climate and produce perfect solar eclipses. A moon whose chemical signature suggests it came from Earth, but whose existence is best explained by a collision with a foreign body. Every piece of the puzzle seems to contradict the others. It's a paradox written across the heavens. So, what is the answer? The truth is, we still don't know for sure. The giant impact hypothesis is still the best model we have, but the scientific community is actively working to solve its paradoxes. Some scientists are exploring modified impact scenarios. Perhaps Theia was made of ice, or maybe there were multiple, smaller impacts. Others are re-examining the idea that the Earth and Moon form together as a double system, though this theory has its own set of challenges. New missions to the Moon are collecting more data right now. They are analyzing rocks from the far side, studying the composition of the lunar poles, and mapping the Moon's gravity in unprecedented detail. Each new piece of information helps us refine the story of our cosmic companion. But the central mystery remains, the sheer, breathtaking improbability of it all. The Moon's perfect orbit isn't just a quirk of astronomy. It's a fundamental part of what makes our planet a living, breathing world. It feels less like a random accident and more like a finely tuned instrument. Perhaps someday we will find a definitive answer. But for now, the next time you look up at that pearly glow in the night sky, remember that you're not just looking at a rock. You're looking at a 4.5 billion-year-old mystery, a cosmic coincidence, a paradox that made our existence possible. What do you think? Are we the beneficiaries of a 1 in a trillion cosmic lottery ticket? Or is there more to the story of the Moon that we have yet to uncover? Let me know your thoughts in the comments below. And if you enjoyed this journey into one of the universe's greatest mysteries, be sure to hit that like button, subscribe to the channel, and turn on notifications so you don't miss our next exploration. Thanks for watching.